In this video, the learner will solve for missing measures in triangles using trigonometric equations. Just to recall SOHCAHTOA here, these are the definitions of sine, cosine, and tangent. Each one of these represents an equation that we could substitute values into. So we could substitute angles in or side measures for the opposite side, hypotenuse, and adjacent legs. So, for example, find the missing sides of this triangle. Well, we know that this is a 30, 60, 90 triangle because we have 30 degrees. So, of course, we could use our 30, 60, 90 pattern, x, x root 3, and 2x, to find those sides. What if we wanted to use trig ratios to find the sides? We could use the acute angle 30 degrees that we were given and find the opposite side and the adjacent side here. So we were given 16, which is the hypotenuse. So over here in our trig ratios, we know we could use one that includes the hypotenuse. We also know what our angle is, so we know that that will be our x degrees. So how about sine of 30 equals opposite, which is m, over 16. Well, to be able to solve for that variable m, I would need to multiply both sides by 16 and get m equals 16 times sine of 30. And I can plug 16 times sine of 30 into a calculator. The sine, cosine, and tangent are all just functions of those angles. It's just another operation being performed on that number. So I can plug 16 sine 30 in the calculator, and notice I get 8. Well, 8 is what the 30 should have been in that 30, 60, 90. So what if we want to solve for that adjacent leg? Well, r is adjacent to 30, and we can use the hypotenuse to solve for it. If we're going to use adjacent and hypotenuse, we know we're going to use cosine. So cosine of 30 equals n over 16. To solve for n, I would multiply by 16 on both sides. And I can plug 16 times cos of 30 into my calculator. 16 cos 30 gives me 13.856. Well, it's supposed to be 8 root 3, so let's compare those measures. 8. So notice that those are the same, 13.856, 13.856. So we were still able to get 8 root 3. Now, a lot of times using sine, cosine, or tangent, we won't be able to get that radical format. So we need to know how to put these in the calculator. So we are going to find each value of the trig function in our calculator. So I'm going to put in cos of 41, and I get 0.7547. I'm going to round to the nearest 10,000. That is the 4th decimal place. So that is that function. Sine of 78, if I put that in the calculator, is 0.9781. Now, in most calculators, you have to make sure the calculator is in degrees. And I'll show you in class how we can make sure to do this. In this example, we're going to solve for the variable using the given angles and the side that we're given. Notice we can't use 45, 45, 90 or 30, 60, 90 because our angles are 21 and 69 and 90. Notice we can't use Pythagorean theorem because we don't have two sides of that right triangle. So our only other option is to use trig ratios. The first thing that you always want to do is choose the angle that you want to work from. So let's say we choose 21. Well, from 21, our x is opposite. Our 9 is our hypotenuse. So from 21, x is opposite, and we have our hypotenuse, so O and H go with sine. Therefore, we can use sine of 21 equals opposite over hypotenuse. Then we have our trig equation set up, and now we can solve it. So multiply by 9 on both sides, and have 9 times sine of 21 give us 3.2253. What if we would have chosen the 69 degrees? Well, then the x value would have been adjacent to that angle. So x would have been adjacent, 9 would have been our hypotenuse, and we would have used cosine. So if we wanted to use cosine, we would use our 69-degree angle and have adjacent over hypotenuse. Multiply by 9 on both sides to get x by itself, and 9 times cos of 69 will give us 3.2253. Notice as I plug those in the calculator, 9 times sine of 21 and 9 times cos of 69, I get that same value for x. So there are more often than not multiple ways to solve and get the same correct answer. Let's take a look at another example. Here we're given the 13 as our hypotenuse. We're given that we have 37, 53, and a 90-degree angle. So we know we're going to have to use trig ratios to be able to solve it. If we choose our 37-degree angle, the x is adjacent to it, and 13 is our hypotenuse. So we have to use cosine. So x is our adjacent side, 13 is our hypotenuse. Multiply by 13 on both sides, and then we can plug that in our calculator and get 10.3823. So the trick is first to choose the angle that you want to work from. If we would have chosen the 53, we would have used opposite over hypotenuse. So we would have used sine of 53. So choose your angle first, and then solve your trig equation. Here are two examples where I want you to solve using trig ratios for x and y.